Welcome to this explainer. Today, we're taking something incredibly common, honestly, maybe even a little bit boring, and we are going to transform it entirely. We're turning a mundane, often overlooked side dish into a highly precise, high-stakes culinary science experiment. We are diving deep into the exact science behind the osmotic acidic slaw protocol. So get your lab coats ready because this is literally going to change the way you look at vegetables forever. We've all been there, right? Staring at that watery cabbage tragedy you're probably used to. Those bland, soupy messes sitting at the end of the picnic table. We are going to contrast that today with the crisp, chemically perfect result we're actually aiming for. Our goal is a highly acidic, palate-cleansing masterpiece. It's a night and day difference, and honestly, it all comes down to controlling the chemistry. So here is your laboratory briefing for today. We're going to cover the soupy slaw problem, Phase 1, osmotic desiccation, Phase 2, acetic emulsion, Phase 3, cellular integration, and finally, troubleshooting any protocol defects. All right, kicking things off with Section 1, the soupy slaw problem. Every good experiment starts by identifying the antagonist, and in our case, the enemy of a perfect slaw is something incredibly simple: water. Think about what goes wrong in most kitchens. If you skip the critical prep step, the raw cabbage is simply going to weep its internal water straight into your dressing. It completely dilutes your carefully crafted flavors from the inside out, leaving you with that sad, flavorless puddle at the bottom of the bowl. We absolutely have to stop this weeping before it even starts. Which brings us to Section 2, Phase I, osmotic desiccation. Let's initiate the first phase of our experiment to aggressively target and remove that water content. Now, osmotic desiccation sounds like something straight out of a biology textbook, right? But it relies entirely on a really elegant core principle of physics and chemistry. By using salt, we can physically extract the internal water from the organic matter. We're literally forcing the moisture out of the vegetable by breaching its cellular defenses. To do this, we begin with a very precise base. We need 4 cups of finely shredded organic red cabbage, 4 cups of organic green cabbage, 1 cup of julienned organic carrots, and exactly 1 tablespoon of kosher or coarse sea salt. And that red cabbage isn't just there to look pretty, it provides anthocyanins and a distinctively peppery bite that is going to react beautifully with our acid later on. Okay, execution time. Step 1 is the purge. You sprinkle that tablespoon of salt over your veggies, toss them vigorously to ensure maximum surface contact, and then you wait. Let it sit completely undisturbed for 30 to 60 minutes. Step 2, the extraction. You're going to take handfuls of this purged cabbage and literally wring the life out of it. Squeeze out as much water as humanly possible by hand. And whatever you do, do not rinse it. While your bowl is sitting there completely undisturbed during the purge, an intense microscopic reaction is actually occurring. The sodium is aggressively pulling the water outward through the cell walls. The salt will breach those cell walls and draw out the internal water via osmosis. You are fundamentally changing the cellular structure of the vegetable right on your countertop. Moving right along to Section 3, Phase 2, acetic emulsion. With our cabbage successfully desiccated, we need to construct a stable dressing. Notice how every single ingredient in this dressing has a highly specific functional role. We use half a cup of organic apple cider vinegar specifically to provide complex malic acids. We use 2 tablespoons of organic maple syrup to mathematically balance the sharp pH of that vinegar. We add a 1 tablespoon of organic Dijon mustard to act as our emulsifier, and a teaspoon of celery seeds, which, trust me, are absolutely essential for that authentic aromatic profile. Now, looking at that list, you might be wondering, is the Dijon mustard really necessary? Maybe you don't particularly care for the flavor of mustard and you're tempted to skip it. Well, don't. Doing so will completely ruin the entire protocol. You see, the mustard acts as an essential chemical emulsifier. The proteins inside the mustard literally lock the oil and water molecules together into a thick, cloudy emulsion. Without it, your oil and vinegar are simply going to separate back into their original states, and it completely destroys the texture of the dressing. To actually create this emulsion, you have to introduce kinetic energy. You'll combine your vinegar, syrup, Dijon, celery seeds, and a half teaspoon of pepper. Then, as you slowly pour in a 1/4 cup of olive oil, you must whisk vigorously. Or, if you want a slight shortcut, put it all in a sealed jar and shake it violently. You physically have to force those molecules together. All right, Section 4, Phase 3, Cellular Integration. It is finally time to integrate our chemically stabilized dressing with our structurally compromised cabbage. Pour that beautifully emulsified acid dressing right over your dry, wilted cabbage. Toss in a half cup of finely sliced organic green onions for a sharp kick and mix it thoroughly. And then, this is critical, enforce a strict cold rest. Pop it in the refrigerator for at least 15 to 30 minutes. Do not skip this step, because this is exactly where the magic happens. Because here is the massive physics payoff. Since we aggressively emptied those cabbage cells of their water back in Phase 1, they don't just sit there. They actually act like microscopic sponges now. During that cold rest, they are pulling the highly flavored dressing directly inside the cell walls. The vegetable absorbs the flavor internally rather than just getting coated on the outside. This brilliant reaction is exactly why we went through the trouble of desiccating the cabbage in the first place. Finally, Section 5, Troubleshooting Protocol Defects. Because let's face it, no experiment is totally foolproof, so we have to outline the major defects you might encounter and exactly how to fix them. The first risk is the too salty defect. If you're sensitive to sodium, your mandatory correction is to quickly rinse the cabbage in ice water right after the purge. But, and this is a big but, you absolutely must dry it completely in a salad spinner before adding the dressing, or we're right back to soupy slaw. The second defect is acid burn. If the apple cider vinegar is just overwhelming your palate, it means you failed to properly emulsify the dressing. The oil and vinegar separated, leaving pools of straight acid. Remember, the Dijon is non-negotiable. So now that you understand the hidden science, the cellular physics, and the chemical reactions behind a truly perfect palate-cleansing slaw, it's time to put on your lab coat. Are you ready to execute the osmotic acetic slaw protocol in your own kitchen laboratory? And honestly, it leaves you wondering, what other mundane, everyday dishes are just waiting for a massive scientific upgrade? Thank you so much for joining me for this explainer. Get out there, start experimenting, and I'll see you next time.